we are on part 3 of curve sketching, the relationships between the formulas and the graphs. In this part, what we're doing is we're going to start with the information about the formula, and then we're going to make the sketch. Now, to get all this information, basically I'm saving some steps and things like this to save some time. You start with a function, you take its derivative, you take the derivative again to get the second derivative, you find out when the first derivative is equal to 0. You then find out when the second derivative is equal to 0. And then you find out when the first derivative is positive and when it's negative, and you find out when the second derivative is positive and negative. So you're doing all the kind of number crunching, playing with the formulas, and this is the information that we're going to use. So basically, I'm saving the steps and just starting with a function, and then the information, and we're going to go with it. Okay, so now one of the first things that we want to do is we want to play with the information about the y values. So if you've got points, if you know your points, then go ahead and plot them in. And so what I have here are 3 points. Where did I come up with these 3 points? Well, the one of them is kind of important because it's the x and y intercepts. So we'll be crossing, when we make this graph, we'll be crossing the x and y axis right here at 0, 0. The other 2 points, I got to be honest with you, basically I didn't make up -2 and 5. What happened was when I took the derivative and set it equal to 0, I got the 2 points, -2 and 5. So those were pieces of information that I got from the first derivative. And so I needed to find their y values to plot those points because those are important points. Okay, so then the second part is that you're looking at the limits. You're looking at the behavior of the graph. So with this function, it was a fraction. And so one of the things I had was that I had 2. When I plugged in 2, I got 0 in the denominator. And as you know, we're not allowed to have that. Things blow up. That created the vertical asymptote. So the information that I have down here was the limits. I needed to figure out which direction the graph was going when it was on the left side of 2 and when it was on the right side of 2. So on the bottom one here, the one in yellow, when I'm on the left side of 2, when I'm 2 negative here kind of thing, I'm going to negative infinity. So my graph is going to negative infinity on the left side of that vertical asymptote. And then plugging in some values to find out what's happening on the right side of 2, I found out that I'm going to positive infinity on the right hand side. And then on the left-hand side here, what I was looking at is what happened to the values when we got large negative values. And when we plug in large negative values, the function basically leveled off at 0. And so that's what I was looking at. We got a leveling off to 0 on the left side. We got a vertical asymptote and 2. And again, all this information was from the original function. So I'm getting that out of there. I'm getting my intercepts, and I'm also looking at what's happening when vertical asymptotes, 0's in the denominator, and also for what happens when we get large, small, left side and right side. Okay, so then I've got the first derivative. The first derivative is giving me information about how things are increasing, decreasing, and also for our potential max or mins. So like I told you earlier, my first derivative at -2 was equal to 0, so that's why I knew that this was a valuable point for me. And my derivative was equal to 0 at 5, so I knew that that also was a very important point for me at 5. And so these are my potential max or mins. So then I also looked at when was the first derivative greater than 0? That happened when I was to the left of -2, smaller than -2, or when I was larger than 5. And what happens is I get nice increasing on the left side and increasing on the right side, because that's when our first derivative is greater than 0. It's positive. When the first derivative was negative, that's where I'm getting my decreasing situations here. That happened between -2 and 2, and then between 2 and 5. So we're getting negative slopes. We're getting a decreasing part of the graph. And so with the first derivative, I know kind of a basic shape. We're going to be basically going up to this maximum and then coming down along the vertical asymptote, and then we'll be coming down to this minimum and then going back up. So I have a basic idea, a really good idea of what's going to happen. The next thing we want to do is we want to see our curvature. How does the graph curve? Because a graph can decrease in two different ways, whether it's curving down or curving up in terms of that how things curve. And so with the second derivative information, here's what I've got. My second derivative was positive for the for when I was x is less than -3, and then positive for when x was bigger than 2. So for x less than -3, I get this curving up kind of thing. So my graph is going to increase, but it's going to increase in as I curve up. And then after -3, we're going to have a curving down kind of graph. All right, it's going to bend like a bull upside down. And then for bigger than 2, we're going to have a case where our derivative is our second derivative is positive, and so that's when I'm going to have this curving up here. So we got a curving up here to the right. We got a little curving up here less than -3, and then we've got a curving down between -3 and 2. And so basically we have an idea of what our graph's going to do. It's going to follow along and just kind of do this nice curve that way, and then as you can see, we get a curvature. So when I do the graph, and you can see it now in black here, I got a nice curve here on the right hand side curving up with a minimum there, and then for the left part of the graph, curving up, hit that inflection point, start curving down, hit that maximum, come through this y-intercept, we've got a bend going on here, and then along that vertical asymptote. And so that's how we do this. We use the formula. We take the derivative. We take the second derivative. We set them equal to 0 to find those critical values, those potential max or mins, those inflection points from the second derivative. Then we want to find out when is the first derivative positive and negative to tell us about increasing, decreasing. And then we look at the second derivative to tell us when it's positive and negative, to tell us how things are curving. Is it curving up or is it curving down? So I hope this example was helpful, putting it together kind of things. Take care and have fun with this curve sketching.